today we're just going to hit the last objective, which is to talk about, we're going to talk a little bit about mass and inertia, but primarily when something is at equilibrium. Okay? So we learned about inertia in the previous time when we started these notes. Okay? When two objects that are at rest or in motion receive the same net force, they don't always experience the same acceleration. And that's because force is not the only thing that impacts acceleration and impacts inertia. Additionally, objects that have more mass have more inertia. Okay? So if you have more mass, you resist changes in your motion. Logically, this makes sense to our brains because if you have tried to push a bowling ball and push a soccer ball before, you know that one of those resists moving more than the other, and it's the more massive one. As a result, more force is required to overcome the inertia and for them to experience the same acceleration. So a more massive object requires more force to experience the same acceleration as a less massive object. The next thing we're going to talk about is equilibrium. Okay? Objects that are at rest, so not moving, or objects that are moving with constant velocity are said to be in equilibrium. Okay? In both cases, the net force has to be zero. So you can tell an object is in equilibrium if that object has a net force of zero. The forces have to be balanced. So all objects that are at rest are in equilibrium because in order for them to not be experiencing any motion, the forces acting on them have to be balanced. Okay? And then objects that are moving are going to have to be moving at a constant speed, so they cannot be speeding up or slowing down or changing direction because the net force acting on them has to be zero. All right, as promised, short little section. We just had just a little bit to finish up.